I want to talk this morning about a topic that sort of crosses over the intersection between policy and technology in enabling operations on space. I want you to start by imagining for a second that today you're going to go out and buy a car. And that car you're going to buy today isn't going to actually be delivered for 5 years from now. And once it is delivered, you have to reuse it for the next 15 years to satisfy all of your transportation needs. In addition, you can never change the oil, you can't add more gas, you can't even change out the radio. The decision you make today that gets delivered 5 years from now and has to last you 15 more after that has to be right, and you can't change it. If that was how you're buying a car, how expensive do you think that car would be to be able to last that long and do all those things that you need? And how difficult do you think it would be to make the decision about which car to make? Probably take you a lot of time. Probably a very difficult decision to make. Well, that's basically how we do a lot of satellites today. Because space is a hard environment, because we can't touch them once they're up there, we have to spend a lot of time thinking about exactly what kind of space capabilities we're going to need 10 years or more from now. A lot of time thinking about the design that goes into the satellites that's going to be able to provide those capabilities. Because once we put a satellite in orbit, it's there. It's what we bought. Can't change it, can't upgrade it. And if something goes wrong, it can be very difficult to figure out what happened to that satellite, why something went wrong, and then be able to diagnose what happened. As an example of that, I'm going to show you a short video clip of a satellite called Telcom 1 that had a very bad day in space last summer. That's it down in the lower left. That is a bad day in space. That's what we call an anomaly, a really bad anomaly. And if you're the operator of that satellite trying to figure out what went wrong and what caused that, and what happened to your satellite, and more importantly, how to prevent that from happening to other satellites in the future, that can be a really difficult problem to solve. Because that satellite is in geostationary orbit about 22,000 miles above the equator. And this is probably the best view you're going to have of what happened, aside from maybe some telemetry from the satellite that indicates certain subsystems might have had problems. To add on top of all that, the space environment itself is getting a lot more complex. There's a lot more actors now in space. We're seeing a lot more objects and space debris, and there's a growing risk of potential conflict in space. When the space age started, there were 2 countries that were involved, the United States and Soviet Union. Today, more than 60 countries have at least one satellite in orbit, and that list gets longer every year. Collectively, those 60 countries and all the commercial companies out there currently operate around 1,800 functional satellites in orbit that provide all the services we use. But those 1,800 satellites are up there orbiting alongside 500,000 pieces of space debris bigger than a marble, some of which are as big as a city bus. And most of that debris is concentrated in the same orbits where a lot of the satellites are because they happen to be the most useful. And so that is presenting a growing risk to those satellites, which adds to the more complexity you need. If you're going to be operating in an environment where you could get hit by something, you've got to add a lot more thought to how you're going to buy your satellite, more expensive satellites to make sure they're going to be able to deal with those, or buy more satellites to make sure that if you lose one, you can still keep doing your mission. And as more countries start integrating space into their military capabilities, there's a growing chance that future conflicts on Earth could extend into space, or that something that happens in space could exacerbate tensions on Earth or create misperceptions that lead to conflict. So all of this is happening in the space environment that is already complicated and results in challenges creating satellites. The good news is that there's a quiet revolution underway in the space world that is developing a set of capabilities that can help address many of these problems. And that's known as satellite servicing. Satellite servicing is a broad term that incorporates a whole range of different activities. There are companies around the world that are working everything from satellite inspection capabilities, so you can actually go out and take a look at satellites like Telcom 1, be able to figure out what happened that caused that anomaly, or even better, be able to do periodic checkups to determine things before they get to that level of problem. There's companies working on life extension programs for satellites, so they can go up and dock with existing satellites, help them stay in orbit longer to be able to get more value out of that asset. Other companies are working on even the ability to refuel satellites in the future, so that if something runs out of fuel or gets stranded in a bad orbit, they can go up and refuel it, help extend the life. There are companies that are working on ways to develop components and modular systems that maybe in the future we can use to swap out failing systems on satellites, upgrade systems to new capabilities, or perhaps even assemble whole new satellites on orbit instead of having to build them here on Earth. And finally, there are companies that are working on what can effectively be thought of as tow truck services in space. Your satellite gets stranded in a bad orbit, or runs out of fuel, or it's an existing satellite that happened to die on orbit in its functional area, and we can help move those away, either bring them out of the atmosphere or move them in the graveyard to help manage the space debris problem. All of these are things actively being developed. And they could yield a whole suite of new innovative activities that can improve space. But themselves are pretty challenging. You're talking about, in most cases, getting up close to another satellite, having to figure out where that satellite is, being able to rendezvous and dock with it, interact with it, all of which poses some challenges. So to help address some of this, we at Secure World are part of a team that is launching a new initiative called Confers. Confers is an industry-led consortium of companies and private sector entities that's backed by some seed capital from DARPA. And the goal is to develop standards for satellite servicing. We're going to be working with companies from around the world to develop voluntary consensus standards for how to do rendezvous proximity operations and satellite servicing. At the moment, we're working with a small group of companies that are helping us establish the structure of the consortium, and we plan to launch it publicly in the next couple of months. Once we do, companies and other private sector entities involved in the consortium, or involved in satellite servicing, will be able to join the consortium and participate in the discussions to help develop standards. The goal is that those standards are going to help enable satellite servicing to happen in a sustainable, safe manner, in a way that then helps lead to greater innovation and on-orbit capabilities. Because that in turn will help lead to better applications here on Earth that can help improve our daily lives. So, this is the website. It'll hopefully be up later this afternoon. That's what I've been told. And you can find out more about the consortium and about satellite servicing and how that is going to help enable the future of space. Thank you very much.